Hello, dear students. My name is Ben, and I'm sure you are all doing great, staying safe, healthy at home. Okay, so I'll be taking class 9 and class 10 science, and I'm very excited to start this because even during this period of lockdown, you, uh, you can learn from home. And let me tell you, nothing can stop you from learning. So today, we'll start with class 9 physics portion. So that will be the chapter 8 from NCERT textbook. And the name of the chapter would be motion. So this is what we will start today, motion. But first, before we start, what is physics? Since till class 8, you have studied general science. But now in class 9, we have different types. We have 3 different types we have divided. That is biology, physics, and chemistry. So what is physics in the first place? Physics. So physics is a branch of science. Physics is a branch of science that deals with the study of natural phenomenon. Let me give you an example. We can take planet revolving. Second example, there are lots of examples. Second example, we can say why apple fall towards the ground instead of going upward or right or left, why it falls straight downward towards the ground. Or third, we can take example of movement of wind. Though sometimes even if we don't see, we can feel and we can sense it, okay? And we have lots of example, current. If you see a wire is carrying a current. Why? How? Everything comes under a physics. Clear? Okay, so in physics, one important thing is we study when we deal with the physical quantity. Physical quantity, and this is very important. And you might be thinking that our chapter is physics, but why we have to study everything like physical quantity? Why we cannot like straight jump to our motion chapter? The reason is everything what physical quantity and all that we are going to discuss now will be dealing in this physics portion. Clear? Physical quantities. Okay, so physical quantities is anything which we can measure, like distance, like length, like time. Everything has its own quantities, and everything that we can measure comes under physical quantities. So there are 2 different types of physical quantities, which is very important. The first is scalar quantity. The second is vector. Scalar and vector quantity, and these 2 are very important and which you must know in order to learn physics. So what is scalar quantity? Scalar quantities are those physical quantities which are dependent on magnitude but independent of direction. When I say independent of direction, I'll give you a very simple example. Let's take example this marker, okay? So this marker let's say the length of this marker will say it's 10 centimeter. So I've changed the direction towards the right, it's still 10 centimeter. I've changed the direction towards the left, it's still 10 centimeter. So irrespective of the direction, the length is still the same. So scalar is independent of direction and dependent on magnitude. Magnitude is a unit, is a numerical unit. Clear? Like example of magnitude, say for this pen, the length is 10 centimeter. Okay, and what is vector quantity? Vector quantities are those physical quantities which are dependent on both the magnitude as well as direction. So vector quantities depends on both magnitude and direction. So same for vector, I'll give you a very simple example. I'll give, let's say, force. Force, F-O-R-C-E. Force is not a new word for all of you, but force is a scalar or vector. Force would be a vector quantity. Okay, so let's say everyone, okay, as soon as you wake up, you push the door, right? So that means you have to apply a force towards a certain direction. Clear? Suppose if I want to push a chair, I have to push either in the right direction, or either I have to push it in the left direction, or I have to push upward or downward. So force comes under vector, where it is dependent on both magnitude as well as direction. So to start to learn physics, first you have to know these two physical quantity, which is very important. And class 9 physics, it is the basic foundation for your future studies as well, because the motion which we are studying now, you will take up till class 11. Even for engineering students, they study motion or subtopics related with motion. So this is very important, and to learn the basic knowledge is very important, because if you don't know the basic knowledge from now, you will suffer in your later parts, in your higher studies. Clear? Next topic will be why we have to study the units, or why units is very important. Because you cannot just go to shop and say, hey, give me 2 sugar, right? You have to say, give me 2 kilos of sugar. So units are very important. For distance, we cannot just say the distance between Kohima to Dimapur is 74 or 72. We cannot just say like that. We have to put kilometer. We have to put meter. We have to put centimeter. So units is very important. Clear? Okay, the next point will be system unit. Clear, students? System unit. In physics, we have different units, and these units are very important. So these units are a standard reference. Clear? A standard reference. And before there were various system of unit, like FPS, the second is CGS, the third is MKS. So the first one, FPS. FPS is foot, pound, seconds. So this is for the length, this is for the mass, and this is for the time. So students, I'm just writing a point, okay? So these are all basic introduction. So this L means length. So the first one here, FPS, F stands for foot. That means this one is often used by the British. In British they say 10 foot, 20 foot. Clear? So, and the mass, they use in terms of pound. And the time is common for everyone here, they use seconds. And this one out here is centimeter, gram, seconds. And out here, the third one is meter, kilometer, seconds. So we have before, long time ago, before we have like all this various system of unit, but this created a lot of confusion, students, because during for trade exchange or research project or any scientific research related subject, there were a lot of confusion and there were a lot of misconfusion because the units are different. So there used to be a lot of problem for this. But in France, there was a conference and they came to a conclusion that we should have a simple one common unit for every country. So they came up with International System of Unit. So that is SI unit. SI unit. Clear? So now the SI unit follows which system of unit? The third system of unit. The SI unit, they follow the third system of unit, that is meter, kilogram, seconds. Clear? MKS system. So we follow this one, this third unit, MKS system. Because now in class 9 you have 5 physics chapter, and out of all the 5 physics chapter, you will have a numerical questions. And whenever you'll get a numerical question, you have to convert everything to meter, kilogram, seconds. Clear? Meter, kg, seconds. So, say example, if you get a question, Ramu runs for 5 hours, then you will not express the answer in hour, but you have to convert it into 5 into 60 to adhere to this third MKS, which is SI unit. So I'm sure you are all clear with the system unit, various system unit. Okay, so now we'll start our chapter here, that is motion. So this is the first chapter for physics, that is motion. So the first thing, what is motion? Motion is anything that changes its position with respect to time. Clear? I will give an example. Right now, the time, as you all know, time and time wait for none. Clear? So now, the time is already moving, but I'm not changing my position. So I'm not in motion. Clear? But now, I have changed my position from over here till here. So with respect to time, I have shown some changes in my position. Clear? So that means I'm in motion since I have changed my position with respect to time. Clear? So I will write the definition here to make it very clear. Since now we have already started with the main points like for this chapter. So motion is any object which change, change its position. Any object which change its position with respect to time. So this is the definition of motion. I will give you another example for motion. That is, since this is the period of lockdown, all of you now there's no school, so you are stuck at home. Clear? So now, if it's you wake up at 5. Some of you get up at 5, but some of you, since there's no school, you might be in the bed. You might be like, okay, 5. Time is passing. It's 5, 6, 7. Usually you get up at 5. Clear? Usually you get up at 5, but since there is no school, you are still in the bed. Okay, no school, I'll sleep for another hour. I'll sleep for another hour. So in that case, with respect to time, you are not making any changes. From 5 till 8, you are still in your bed. Clear? Then that is not in motion. Then what we'll call that? So we'll call that rest. Clear? So the definition of rest is just an example of the definition for motion. Any object which does not change its position with respect to time. So here, the definition is simple, just you have to add this one. Any object which does not change its position with respect to time. Clear? So I will give you 2 examples. Let's take 2 students. One is an active student, one is the lazy student. One student usually gets up at 5 and then starts like his daily activity, starts all the cleaning, refresh himself, have breakfast, and do all the activity. And one does not get up on time since he's locked down, so he usually likes to be lazy, like stay in the bed. So we'll say the first student who is active is at motion, because from 5 till 8, he is changing his position, doing all the activities. Clear? But the second student from 5, I'm taking example 5 till 8 a.m. Clear? From 5 till 8, what he likes to do is just be in the bed. Clear? So the first example is for the motion, and second, which is at rest, is which the lazy student example is for the rest. Clear? So now the definition for motion and rest is clear. I'm sure you are all clear with the definition. It's very easy and a practical example I've given. So now the next important point is observation. 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 So now we'll take another example, that is every morning you take a school bus and you go to school. Clear? Physics, okay, physics requires a lot of imagination. So I want you to imagine that now it's time to go to school. So you have already taken the school bus and you're on your way. Clear? So now, before reaching the school, you just tend to look outside. What you will see? You will see trees. Actually, the tree doesn't move, right? The tree is at rest. According to you and me, the tree is at rest. But since the bus is in the motion, and so you are looking outside the window, so now you see that even the tree appears to be in a motion. I'm sure you have all observed that one. Clear? The bus is in motion and you just look outside the glass and you see that the tree appears to be in a motion. Clear? So, but another point observation is, okay, let's take example. Another observation is, let's take from astronaut point of view. Astronaut point of view. Now, if I say to the tree, the building, the school building, the office building, you'll say that it is at rest because they are not changing their position. Clear? They are not changing their position. The building is at rest. But what will happen to, from astronaut point of view, they are going to observe everything outside the Earth. Clear? They are going to observe everything from outside the Earth. So as you all know, as you have been studying from the class 4, 5, you all know that our planets revolve around. So everything will be changing its position and they will be in motion according to an astronaut point of view. Clear? So you often get a multiple choice question where the question will be very simple, but the student always tend to make mistakes. So one thing from here you have to learn is that you have to read the question carefully. Clear? Because from astronaut point of view, it's going to be a different context. Okay. Now, I'm sure you are all clear with the motion, race, and the observation from all different point of view. So our next topic would be distance and displacement. Distance and displacement. Distance and displacement is not a new word for you, but let's see how physics define them. Clear? Okay, students. Our next topic, distance. Distance and displacement. Distance and displacement. Okay? Distance, displacement. Distance, I'm sure, is not a new word for you. Displacement is also not a new word for you, but how physics define them. Clear? So the definition for distance would be the total length of the path, P-A-T-H, covered. And the definition for displacement is the shortest distance between the initial, when I say initial, students, it is the starting point. Clear? Initial, the shortest distance between the initial and the final point. So here's the definition for distance and displacement, and I will explain the major difference between this distance and the displacement. For this, okay, let me show you here a straight line here. I'll show you two conditions. This is the first case, case 1. Clear? And this is case 2. So let me say that we have here A, B, and C. This is 4 centimeter, this is 3 centimeter. 4 centimeter, 3 centimeter, A, B, C. Same here, it's A, B, C. So here it's 4 centimeter, here is 3 centimeter. So it's the same thing. We have, if we total the distance, everything here, it's 7 centimeter here. If we total here in the second case, it is 7 centimeter. Nothing different, but here what happens is from B we are taking a turn, or else it's the same. Clear? So what did I say, students? I said that distance is the total length of the path cover. So this is the path from A till C. So that means here the distance is 4 plus 3 centimeter, that is 7 centimeter. Clear? And if I say displacement, that means the shortest distance. So what will be the shortest distance here? Since it is a straight road, since it is a straight path, the displacement is also going to be the same thing. The displacement is 7 centimeter. It's the same thing here. Clear? But case 2, here you will see the major difference. Here, what is the total distance from A till C? We have to cross A, B, and C. So that means here the distance is going to be 7 centimeter. So one thing you notice here is that from the case 1 and case 2, in both cases, the distance is not changing. And it is 7 centimeter. Because from the definition, it is saying that total length of the path cover. That means we are not focusing on the direction. We are just concerned about the total length from our initial point till the final point. Now, here, what will be the shortest route to reach point C? The definition of displacement is the shortest distance between the initial and the final point. So this is the initial point. This is the initial point. That means the starting point. That means, let's take example from your house. Clear? From your house, you have to go to the school. That means this is your school and this is your house. Clear? So the distance, actual distance is 4, 3. But everyone likes shortcut. So displacement is the other word for shortcut. Clear? So displacement, since displacement is the other word for shortcut, if we apply a shortcut here, then it will be from A till C. That means instead of going all over to B, we have a shortcut here, that is A till C. And that would be 5 centimeter. How we get this one? Because here, B here is 90 degree. That means it's a right angle. So here, that means this is the hypotenuse. So we'll apply a Pythagoras theorem here. So for here the displacement would be, by applying the Pythagoras theorem, having the square root of all the sides, 4 square, 3 square, we have here 16 plus 9. That means we have 25, which the answer would be 5 centimeter. Clear? So see, if we apply a displacement, the displacement is just 5 centimeter to reach your final destination. So here what difference we can see from here is displacement is dependent on direction. Clear? But distance is not depending on the direction. But here in this case, displacement can change. And it is always dependent on the direction. Okay, now distance we represent by just a normal d. Clear? But students, keep in mind, we represent displacement by a letter S. S like in star, S like in sun, okay, letter S. And now, in the beginning of the lesson, I have given a difference between scalar and vector quantity. We are going to apply everything here. Scalar is independent of direction, right? So in this case, distance is a scalar quantity, okay? The distance here, it is a scalar quantity, But displacement is dependent on magnitude as well as the direction. Magnitude means the unit, the numbers. Direction means here displacement has applied the shortcut to reach C. Clear? Instead of 7 centimeter, we're getting 5 centimeter. So displacement is a vector quantity. It's a vector quantity. You should get used to all these names because from now on, we'll be applying everything in our following chapters as well. So now here for displacement, since it is a vector quantity and since vector is dependent on direction, we'll give a bar or an arrow on top of the letter. Clear? From here, now we are clear with the definition for the distance, definition for the displacement, and their representation. Distance is represented by a letter D, or you can write capital D as well. And displacement is represented by letter S. And since displacement is a vector quantity, we would identify this displacement with a bar or with an arrow on top of the letter. Clear? Okay, and what is the SI unit of distance? And what is the SI unit of displacement? What do we write after the number? We write meter, right? So SI unit for both distance and displacement would be meter. And displacement as well, the SI unit would be meter. So this is the SI unit for displacement, the SI unit for distance. So that means they have the same SI unit, that is meter. Clear? Now distance can never be negative. The next important point is distance can never be negative, but displacement can be negative. Why? Because in distance we are just concerned about the total length. So there we don't have to deal with some minus here. But in displacement we have a direction. So if we just take this, now if you're clear with this, shall I wrap? Okay. Now let's take this straight line here, A and B. From A till B, it was 4 centimeter. Clear? But now you're coming back. Now you're coming back and you have stopped at point C. So what will be the total displacement in this case? So let's say that this is 1 centimeter. So in this case, in the graph, as you have learned, if we go towards this side, that means it will be minus. So in this case, the answer that you'll get here is minus 1 centimeter. Minus 1 centimeter. So displacement can be a negative since it has a direction. And direction towards going this side will be negative. Clear? In the graph you have learned, right? Okay. So if you are clear with this one, we'll go to the next important topic, that is speed and velocity. Clear? Speed and velocity. So our next topic would be speed and velocity. Okay, students, our next topic is speed and velocity. Speed and velocity. So speed is to do with distance and velocity is to do with displacement. In the last topic, I have already shared the major difference between the distance and displacement. And if you are clear with distance and displacement, this should be very easy for you, because speed, it's not a new word for you, speed. But speed is total distance covered per unit time. Clear? And velocity is to do with displacement. That means if I say displacement, means it is to do with direction. Clear? And magnitude as well. So velocity is the total displacement occurred per unit time. So this is the difference between them. One is to do with distance and one is to do with the displacement. And now what is the SI unit of the speed and velocity? The SI unit would be the same. It would be meter per second. That is the SI unit. And the SI unit for velocity would be the same, meter per second. This would be the SI unit. So here we have the same SI unit here. Now, you will get a numerical. What calculate the speed or calculate the velocity? Then the formula is very simple. Is very simple. For speed, the formula would be distance by time. Clear? Distance by time. Distance here for distance. Time. So if you are told to calculate the speed of anything, then you will apply this formula. Speed is distance by time. And now if you are told to calculate the velocity, so velocity, since it's a vector, we would indicate with this arrow or a bar. So it will be displacement upon time. So you, my dear students, you please note down the difference between the speed and velocity and this formula, because using this formula will calculate the velocity, using this formula will calculate the speed. Clear? So I have drawn like this here for you. Okay, so whatever we have learned today, I would appreciate if you note it down in your notebook and then go through it. Clear? Because these are the important topic like for the motion chapter, and without knowing this, you will struggle in the next chapter as well. Clear? So in next class, we will start with a uniform and non-uniform motion. We'll see some equation. We'll start a numerical, and I'm telling you, it's going to be a lot of interesting if you put more effort, and then if you practice, and if you just go through all the notes, it's just everything is relatable, everything is practical. It's what we see every day in our lives. Clear? So please note down this difference between the speed and velocity, all the SI unit, the formula, and their definitions. These are very important. Thank you so much.